member of the ring must be sp2 or sp, and third one is, so molecule must obey Huckel rule, that is a 4n plus 2 pi electron. So molecule must have 4n plus 2 pi electron, okay, where n equal to 0, 1, 2, 3, 4, and how many pi electron molecule must have? Either either 2, 6, 10, 14, 18, 22, 4, 4, increase 4, 4, but remember first number is 2, okay. Then so non-benzenides, okay. Then aromatic compounds are classified into two types, benzenoid and non-benzenoid. So what are the benzenoid? Which contain at least one benzene ring. Benzenoids are again two types, one fused and that is isolated, right, that is also over. Next is second one, non-benzenoid. So non-benzenoid I think started, right, that is also completed. Non-benzenoid also some example completed, tropylium completed, right, fine, okay. Now write the question. Right, identify the one second, not question, we will finish first anti-aromaticity, then we next will write identity. Now next write anti-aromaticity. Anti-aromaticity. So we have completed what is aromaticity with example. Next is anti-aromaticity. Tell me. So it is quite opposite to aromaticity. So what is aromaticity? The property which gives the extra stability to organic molecule, particularly like benzene or benzene-like molecule. So here opposite, the property which destabilize the molecule, particularly like benzene-like molecule, called what? Anti-aromaticity, and substance are called what? Anti-aromatic substance or compounds. Then why anti-aromaticity destabilize the molecule? The reason is here aromaticity stabilize the molecule because in aromaticity electron enters into BMO, bonding molecular orbital, whereas in case of anti-aromaticity electron enters into anti-bonding molecular orbital. Therefore here anti-aromaticity destabilize the molecule because electron enters into anti-bonding molecular orbital. The next, what are the condition for aromaticity? So what are the anti-aromaticity conditions for anti-aromaticity? There are three conditions. First two conditions are same. Tell me, what is the first condition? Molecule must be cyclic and planar. So molecule must be a cyclic and it should be a planar. So what is the meaning of planar? All the atoms of the molecule should be touches to one plane, means should be placed on one plane, should be lies on the one plane. Second one, each member of the ring must be either sp2 or sp. So these two conditions are same, but molecule must contain 4n pi electron, not 4n plus 2 pi electron. If the molecule contain 4n pi electron, that is a anti-aromatic compounds. For example, where n equal to, in case of aromatic n equal to we have taken 0, 1, 2, 3, but here n equal to minimum 1 should be there. 1, 2, 3, 4, so on. If you take 0, what it become? 4 into 0 it becomes 0. That means no pi electron. No pi electron means not at all, it is not at all a aromatic, anti-aromatic. Therefore now n should be 1, 2, 3, 4. Suppose if n equal to 1, n equal to 2, 3, 4, 5, tell me what is the pi electrons? If n equal to 1, there are 4 pi electron. It means molecule minimum they must have how many? 4 pi electrons, or 8 pi electron, or 12 pi electron, or 16 pi electron, 20 pi electron, right? 4, 4, increase 4, 4. If molecule having any one of these pi electron, this should be anti-bonding, it should be anti-aromatic compound, right? For example, let us take, it is a cyclopropene anion. Tell me, is it aromatic or anti-aromatic? So tell me, first condition, is it cyclic or not? Cyclic. Planar or not? How do you say planar it is? All the members of the ring must be either sp2 or sp. This is sp2, it is sp2, it is also sp2. Actually carbanion should be sp3, no, but it is what? Resonance. It is involved in resonance, therefore this electron pair should not be involved in hybridization. Therefore all sp3, all sp2, it is it is how many pi electron? It is, here is 2, here is 2, 4 pi electron, therefore it is a anti-aromatic. 4 pi electron. Next, one more example. Let us take, it is a cyclobutane but 2 double bonds. Tell me, is it cyclic or not? Planar or not? All are sp? No. sp2? No. Therefore how many pi electron? 4 pi electron, therefore it is also anti-aromatic. Next, let us take cyclopentane having 2 pi bond and a positive charge. Tell me, tell me, all are sp2 and carbocation sp2, of course. So therefore it is a 4 pi electron, it is also anti-aromatic. Next, it is a, for example, let us take 6-membered ring, 1 2. How many pi electron? 4 pi electron, it is also anti-aromatic. One more example, let us take 7-membered ring, how many pi electron? 6 plus 2, 8 pi electron, it is also anti-aromatic. Okay. Next, one more example. One second. Tell me, it is also 8 pi electron, it is also anti-aromatic, right? It is a octa-membered ring, 8. Okay, right on. So like that you can identify which is anti-aromatic, right? Anti-aromaticity, right? The property anti-aromaticity, the property which gives instability to organic molecule, the property which gives instability to organic molecule called anti-aromaticity, the property which gives instability to organic molecule called anti-aromaticity. In anti-aromaticity, electron enters into electrons enters into antibonding molecular orbital. Electrons enters into antibonding molecular orbitals. Next, conditions for anti-aromaticity. Conditions for anti-aromaticity. One, molecule must be cyclic and planar. Molecule must be cyclic and planar. 2, 2. Each member of the ring must be either sp2 or sp hybridized. 3. Molecule must have 4n pi electrons. 4n pi electron, where n equal to 1, 2, 3, 4, so on. Take if n equal to 1, 2, 3, 4, 5. So remember this number 4. If you remember 4, then add 4, 4, 4. Aromatic first number is 2. Anti-aromatic first number is 4. Okay, take example. Okay, finished. Next is non-aromatic. Non-aromatic. So what is aromatic, what is anti-aromatic, and what is non-aromatic? Questions also like this only. Which of the following aromatic, which of the following anti-aromatic, which is non-aromatic? Okay, then what is a non-aromatic organic compound? Say non-aromatic organic compound is a cyclic compound which is not having planarity. What is the meaning of this? A cyclic compound which is not having planarity called non-aromatic compounds. So which is not having planarity means, very good, it should be not sp2 or sp. So other than this, which is the possibility? Only sp3. It means, so a cyclic ring must have at least one carbon is sp3. In a cyclic ring, if one carbon has sp3, it is a non-aromatic. Okay, third one. A cyclic compound which is not having planarity, a cyclic compound which is not having planarity called non-aromatic compounds. A cyclic molecule which is not having planarity called non-aromatic compounds. That is in cyclic ring at least one carbon should have, in cyclic ring at least one carbon should have which hybridization? sp3 hybridization. One carbon should have sp3 hybridization. So example, tell me, let us take this. Come on, tell me, is it aromatic or anti-aromatic? Non-aromatic. First one, non-aromatic. Why? Because you see the carbon is sp3, no. So there is a one carbon has sp3, therefore it is neither aromatic nor anti-aromatic, it is non-aromatic. Here there are two carbons having which relation? sp3. It means if any one carbon has sp3, it loses planarity. So that means molecule is not a planar. Now tell me, molecule is not a planar means what? It doesn't have planarity. It means on this carbon there are of course two hydrogen like this. Okay, in two hydrogen, one above the plane and one is below the plane will be there. It is like this. If one hydrogen below the plane, other will be above the plane like this, and these two bonds are on the plane. It means automatically when carbon gets sp3, it loses its planarity. So therefore here also same, there are two carbon. Next one more, you need not to see number of pi bonds, pi electrons, it's not required. One more example, it is also non-aromatic. It is also non-aromatic because there is one sp3 carbon. Okay, write down question. Identify the aromatic, anti-aromatic, aromatic, anti-aromatic and non-aromatic compounds in the following. Okay, questions also like this we can expect. Take down. Okay, so just identify aromatic, anti-aromatic, non-aromatic. Tell me, first one, is it aromatic, anti-aromatic or non-aromatic? Huh? Tell me. Aromatic. Why? So see the number of, now it is a cyclic planar and number of pi electrons are how many? 2, 4, 6. Okay, there are 6 pi electrons, right? 6 pi electrons. Then what about this lone pair? The lone pair electron present on nitrogen, whether they are delocalized or localized? They are localized. Why not delocalized? It means if these lone pair electron involved in resonance, it become total how many electron? Total become 8 electron. If molecule has 8 electron, it become anti-aromatic. And moreover, in anti-aromatic compound, electron enter resonance, those electron enters into anti-bonding molecular orbital, which become most unstable. That's what these lone pair electron do not involved in resonance. That's what it is a 6 pi electron, it is aromatic. Next, second one. Now what about this lone pair now? Now there is a one lone pair, but this lone pair involved in what? Resonance. If they involve resonance, how many pi electron? 2, 4, it is 2. There are 6 pi electron, it is also anti-aromatic. Now tell me, what is the difference between it is a pyridine, it is a pyrrole? Its name pyridine, pyrrole. So pyridine, pyrrole both are having nitrogen, but these nitrogens are what? They are localized. Now here the lone pair are, they are delocalized. Okay. So therefore, now there was a question. Among pyridine, pyrrole, which is more basic? Among pyridine and pyrrole, which is a more basic? Both are having one lone pair electron each. Tell me, which is more basic? Pyridine is more basic because in pyridine there is a localized lone pair. These localized lone pair electron ready to donate, right? Therefore, here delocalized lone pair electron, they are not ready to donate. So therefore, which is more basic? Pyridine is more basic than pyrrole. Okay, this is we have studied in amine topic also. Okay, fine. Next here, so oxygen has 2 lone pair. Come on, tell me, if there is a 2 lone pair, out of 2 lone pair, how many lone pair involved resonance? 1 lone pair is enough. If 2 lone pair involved, it become anti-aromatic. Therefore, now tell me, 2, 4, 6, how many? 6 pi electron, it is also aromatic. Next, here one lone pair involved, 2, 4, 6. It is also 4 pi electron aromatic. Yes or no? Now tell me, it is called furan. In furan, there are 2 lone pair. Out of 2 lone pair, one is a localized, another is a delocalized. One localized, other lone pair delocalized. Next, there are 2 lone pair. It is a aromatic or anti-aromatic? Non-aromatic. Why? There are 4 sp3 carbons, right? Next, so here also nitrogen has one lone pair. Tell me, how many pi electron? 10 pi electron. It is 10 pi electron. 2, 4, 6, 10. 10 pi electron aromatic. 2, 6, 2, 6, 10. Next here, it is aromatic or not? Aromatic. Why? Again, what is the difference here? It is a aromatic with the lone pair is what? Delocalized. No. Yeah, localized. Okay, localized. Okay, if the electrons are localized, they involved in hybridization. Yes or no? If electrons are localized, they involve hybridization. If electrons are delocalized, they do not involved in, they involved in resonance. So the same lone pair do not involve resonance and hybridization. It is impossible. Next, here tell me. Now here also it is a 4 plus 5. It is 10 pi electron. Tell me, 10 pi electron. It is a aromatic. Now aromatic with delocalized or localized lone pair. So here this is delocalized. Delocalized lone pair of electron. Next, tell me, it is aromatic. Why? Number of pi bond, 1, 2, 3, 4 pi bonds and one lone pair. It is 10 pi electron. It is also aromatic. Next, tell me quickly. It is how many pi electron? 4 pi electron, anti-aromatic. Next, 6 pi electron, aromatic. Next, how many pi electron? So how many pi electron? 8 pi electron. It is anti-aromatic. Next, 4 pi electron, anti-aromatic. 4 comes in anti-aromatic, no? Now tell me this is different. Is it aromatic or anti-aromatic? Now tell me, among carbon, this is carbon and hydrogen. Among carbon, hydrogen, whose En is more? Whose electronegativity is more? Oxygen. Therefore, this pi electron shifted on oxygen. Oxygen gets negative charge, carbon gets positive charge. That means this carbon gets positive charge. Then calculate the number of pi electron. 2 pi electron. Cyclic planar 2 pi, no? 2 na 4. 2 only. You see in the ring, you just see one ring. Cyclic ring has how many pi electron? 2 pi electron. Therefore 2 pi comes under in aromatic. Next, here also negative. This pi bond shifted. Here carbon gets positive. How many pi electron? 4 pi electron. It is anti-aromatic. Next, tell me here. So this is again another different question. So here, now tell me, there are 2 rings. One is a cyclo, like a 5-membered ring, 7-membered ring, right? Now there are 2 possibilities. Suppose if this pi bond shifted this side, okay, then tell me, if the pi bond shifted towards 5-membered ring, this is get negative charge, it is get positive charge. Now tell me, aromatica, anti-aromatica. You see the both. It become how many? 2, 4, 6. It is 6 pi electron aromatic. It is 6 pi electron. It is also aromatic. Suppose there are another possibility. Another possibility reverse. If it get positive charge, it should get negative charge. Now it becomes what? 4 pi electron anti, 8 pi electron anti. It means that is not possible. Only this is possible. Because molecule always try to exist stable. That is aromatic form only, not anti-aromatic. Because when molecule exists anti-aromatic, electron enters into anti-bonding molecular orbital. It is molecule do not try to exist in anti-aromaticity. That is not possible. If it is inevitable, that can be. Now tell me here. So here also it is negative, this is positive, 6 pi electron aromatic. Next, 6 pi electron aromatic. Next, 2 pi electron aromatic. Next, 8 pi electron anti-aromatic. 8 comes in anti-aromatic. Next here, 8 or not? 8 pi electron. See, both are same molecule. I have written in different form, that's it. Tell me, cyclic ring has how many carbons? No, 1 second. 1, 2, 3, 4, 5, 6, 7. No, both are different. It is 8 membered. It is 12 membered. Tell me, it has how many pi electron? 12 pi electron. That is anti-aromatic. Okay. Yeah, this one. Oxygen has 2 lone pair. Wherever oxygen comes, 2 lone pair, nitrogen 1 lone pair. 6 pi electron. That is aromatic. Next. Now see here there are 2 lone pair, but now we need to see that how many electron can involved. But actually how many electron supposed to be involved, should be involved. So if it is required, 2 can also involved, but is it required? No. Why? No. One second. No, if there are 2 lone pair, out of 2 lone pair, can 2 lone pair electron involved in resonance at a time? At a time not possible. At a time from single atom 2 lone pair involvement is not possible, because electrons also present in perpendicular direction, right? One electron present on x axis, other electron present y axis. X axis and x electrons are perpendicular. That's what, if x electron involved in resonance, y electron comes in perpendicular. That is we study in chemical bonding. That's what. So there is an involvement of only 1. If 1 involved, this another cannot involved. If this involved, this cannot involved. So that's what. How many pi electrons here? 4 pi electron. That's what? Anti-aromatic. Next, there is a 2 lone pair, 6 pi electron. That is howda? Non-aromatic, because sp3 carbon is there. No. Tell me. Non-aromatic. Yes or no? Non-aromatic. Next is how many electrons? 14 pi electron. 10, 14. Aromatic, no. Aromatic. Next, 2, 4, 6, 8. 1 lone pair. 10. So 10 pi electron. Aromatic. Next. 20? Which one? This one, No, I don't want phenyl. Phenyl is anyhow aromatic only. Phenyl ring. You see this ring. 2, 4, 6. 6 pi electron aromatic. Okay, so write down question. Which of the following amine is more basic? Which of the following amine is more basic? More basic. Okay, so in 1, 2, which is more basic and why? Okay, in basic nature we have studied sp3 nitrogen is more basic than what? sp2 nitrogen. Which is more basic than sp nitrogen? Basic strength, because electronegativity increases, basic strength is decreases. Electronegativity increases, acidic strength is increases. sp3 nitrogen more basic, sp2 nitrogen, sp3, sp2, sp nitrogen. Okay, now tell me first, you calculate this. No, what is hybridization of this nitrogen? So what is the hybridization of this nitrogen? So number of hybrid orbital equal to sigma bond plus lone pair. How many sigma bond? 1, 2. How many lone pair? 1. It means sp2. Now here, how many sigma bond? 1, 2. Lone pair is? No, we need to see whether lone pair involve resonance or hybridization. There is a one lone pair, but whether this lone pair involved or hybridization or resonance, it is involved in resonance. It has to, otherwise molecule do not exist. Because 6 pi electron, no. To get 6 pi electron, these electron involved resonance. When these electron involved in resonance, then how many sigma bonds? 1, 2, 3. So therefore, what is hybridization? sp2. It means both the nitrogen have sp2. Okay, both the nitrogen having sp2, but one has delocalized electron. This is delocalized lone pair electron, and has what? This is localized lone pair electron. Tell me now, which is more basic? So first one, localized lone pair. They are readily available to donate to acid. Okay. Next, right, homologous series. Right, this is the order of basic strength. sp3 nitrogen, order of basic strength. Okay. Next, right, homologous series. Homologous series. Right. So what is homologous series and characteristics of homologous series? Tell me. In homologous series, for example, if I take alkane, can you tell me? What is the general formula of alkane? CnH2n plus 2. Okay. So what is the first member of the ring? Methane. Second member? CH3, CH3. Third member? CH3, CH2, CH3. And see, when you write each member, what is increases? What is increases? CH2 group increase, no? Okay. Then tell me, now all these members of the alkane will have same general formula. It means, what are homologous series? The series in which all the members or all the compounds having same general formula called homologous series. Therefore, these are all the homologous series of alkane. Like similarly, you can write homologous series of alkene. So what is alkene general formula? CnH2n minus 2. The first member of alkene is ethene. H2, sorry, okay, alkene. First member is CH2CH2. Second member is, third member is CH3CH2. Then from each member, when you write each member, what is increases? So one CH2 group goes on increases. So therefore, now all these members also called homologous series of alkene. Therefore, what is the meaning of homologous series? The series of compound in which all the members have same general formula. Okay, all these have same general formula. Then what are the characteristics of homologous series? First characteristic, see, the consecutive members of homologous series must be differ by only CH2. For example, first two members, second and third, third and fourth. Any two adjacent member, that is called consecutive members. Any two adjacent members must be differ by CH2 and must be differ by molecular weight. How much? It is 14. The molecular, say, for example, what is the difference between molecular weight of methane and ethane? 14. What is the difference between the molecular weight of ethane propane? 14. So what is the difference between these two? CH2. That means each consecutive members must be differ by CH2 group and differ by molecular weight is 14. Next, suppose second one, if the molecule has like functional group, if molecule has functional group, all the members should have same functional group. For example, it is take alkyne and alcohol. Okay, the first member of alcohol is CH3OH, second member is CH3CH2OH, and next also one carbon goes on increases. It means, see, now here if any one member has alcoholic group, OH group, all the member must have same group. That means if the functional group is present, all the members must have same functional group. That is a second point. Third point. Then what about methods of preparation? So all the members must have same method of preparation. Suppose like ethene can be prepared by something so and so method, like coal based electrolysis. There is one method you can prepare ethane. So ethene can be prepared by coal based electrolysis. Even propene, butene, pentene, hexene, all these members can also be prepared by same method. That means, so all these members of the homologous series will have same method of preparation. Next, fourth one. Then what about chemical and physical property? Chemical property, when comes to chemical property, all the members must have similar chemical property. Not exactly same but similar. For example, alkane. Alkane undergo free radical substitution, that is methane. Ethane, propane, butane, all these undergo free radical substitution reaction. For example, alkene. Alkene undergo electrophilic addition reaction. Ethene, propene, butene, pentene, all these undergo electrophilic addition reaction. It means they must have similar chemical properties. Next, fifth one. What about physical property? So physical property is there should be a gradual change in physical property. They should not have same physical property. Gradual change. For example, you take alcohol. So what happened? The boiling point of alcohol down the homologous series, as the number of carbon atom increases, boiling point is increases. Methyl, ethyl, propyl, butyl. So boiling point is gradually increases. What happens? Solubility. Solubility, methyl alcohol is more soluble. As the size of this alkyl group increases, what happens? Solubility decreases. Methyl, ethyl, propyl. So as the size of the alkyl group increases, solubility decreases. That means there is a gradual change in the properties, physical properties. It may be increase or decrease. So it is about homologous series. So what is the definition and 4 characteristics? Right on. Definition. The series of compounds in which all the members have same general formula. The series of compounds in which all the members have same general formula called homologous series. Take example. Alkane, alkene, alkyne, okay, go on many. What is the formula of alcohol? CnH2n plus 1 OH. Right, next, characteristics. Characteristics of homologous series. 1. Right. Two consecutive members or successive members differ by CH2 group. Two consecutive members or successive members differ by CH2 group and molecular weight is 14. 2. If functional group is present, all the members must have same functional group. If functional group is present, all the members must have same functional group. 3. All the members of the homologous series should have same method of preparation. All the members of the homologous series should have same method of preparation. 4. All the members of the homologous series should have similar chemical properties. 4. They should show gradual change in physical properties. They should show gradual change in physical properties. Next, right? IUPAC nomenclature of organic compound. IUPAC nomenclature of organic compound. Okay. Right. So IUPAC nomenclature of organic compound. Tell me. So IUPAC name has how many parts? 3 parts, right? Right on. IUPAC name has, or name of organic compound has, IUPAC name of organic compound has 3 parts. What are the 3 parts? 1. Root word. 2. Prefix. And 3. Suffix. Right? So there are 3 parts. So every organic compound usually it has 3 parts. One is a root word, second one is a prefix and a suffix. This root word again classified into, it has how many part? 2 part. One is prefix has 2 part. One is primary prefix, secondary prefix. Yes or no? And what about suffix? Suffix also again 2 types. One, primary suffix, and 2, secondary suffix. Got it? Now let's see one by one. So what root word indicates, and important, what is a prefix and what is suffix? Come on, tell me. First one is root word. So what is a root word, or what root word indicate? So this root word indicates the number of carbon atom present in a parent chain, right? It indicates a given organic compound has how many number of carbon atom in a parent chain. For example, if the parent chain has only 1 carbon, what is the root word? Meth. So 2 carbon, eth, 3 prop, but, pent, hex, hepta, septa. Hept. In organic, hept, whereas in case of inorganic, sept. It is hept, oct, nun, dec. Okay, so therefore it indicates presence of number of carbon atoms in a parent chain. It indicates number of carbon atoms present in a parent chain. It indicates number of carbon atom present in a parent chain. And tell me, if the number of carbon atom is 1, C1, what is the root word? Meth. C2, eth. C3, prop. C4, but, not but. C5, pent. C6, hex. C7, hept. C8, oct. C9, nun. C10, dec. So therefore root word indicates the number of carbon atoms present in a parent chain. Next is prefix. Right. So prefix has 2 parts again. One is a primary prefix, and second one is a secondary prefix. So let's say first what is primary prefix. Come on, tell me. So what is a primary prefix? What does primary prefix indicates? See, so this primary prefix indicates the molecule is cyclic or acyclic, right? If the molecule is cyclic, it is called cyclo. If the molecule is acyclic, open chain, that is called no prefix, right? So it means it indicates molecule is cyclic or acyclic. Okay, let us say in first column take molecule, in second column is what is primary prefix. Okay, Satvika, if the molecule is acyclic or open chain, what is the primary prefix? It has any primary prefix? No. So there is no primary prefix. No means it is not no. No andre name ಅಲ್ಲಿ no ಅಂತ ಬರಿಬೇಡ್ರಿ, ಅರ್ಥ ಆಗಿಲ್ಲ. It means it has no. Okay, ಬುದ್ಧಿವಂತರಲ್ಲ. Next, if it is a mono, like one cyclic ring, and tell me it is a just cyclo. Next, if it is two cyclic ring, bicyclo. In our syllabus we study bicyclo, both cyclo bicyclo compounds we have in syllabus. Tricyclo not there, but if it is a three cyclic rings, which is called tricyclo also. So cyclo, bicyclo, tricyclo, this is primary prefix. Okay, so therefore primary prefix indicates the whether molecule having cyclic ring or acyclic ring or nothing but open chain. Next, secondary prefix. Secondary prefix. Tell me. So what does secondary prefix indicates? It indicates presence of substituent, right? So therefore, it indicates presence of substituent. Okay, substituent. Okay, for example, let us take first column substituent and in second column secondary prefix. Okay, if the substituent is something R is a alkyl, methyl, ethyl, propyl, no, R, it is alkyl. Next, if it is NO2, nitro. If it is NO, nitroso. If it is X, halo, chloro, fluoro, chloro, bromo, iodo. If it is OR, it is alkoxy, methoxy, ethoxy. If it is C6H5, phenyl, not benzene, C6H6 benzene, C6H5 phenyl. If it is benzene having CH2, benzyl, right? If it is C double bond O, there is a benzene ring. It is a benzoyl. See how different it is. Benzyl, benzoyl. Next, if it is N double bond N, it is diazo. Diazo. Okay. Okay. Now, for example, now let us take, it is a alkene. Alkene lost one hydrogen, it gives what? Alkyl. Alkene, alkyl. Methane, methyl. For example, CH4, okay, minus H, CH3, which is called what? Methyl. Methane, methyl. Like for example, alkene. Alkene lost one hydrogen, because most of the time we will get alkyl is a substituent is very commonly. That's what we are studying in detail about alkyl. Okay, tell me, alkene, hydrogen, it is alkenyl. Alkene, alkenyl. Like for example, ethene. Okay, so remove one hydrogen. It is ethene, ethenyl. Propene, propenyl. Next, if it is a alkyne, so remove one hydrogen. Alkynyl. Alkyne, alkynyl. Like for example, ethyne, it gives ethynyl. So ethine gives ethynyl. Okay, so therefore alkyl, alkenyl, alkynyl. Okay, now let's see some important example for alkyl. Okay, tell me. So simple one is CH3. Come on, tell me what is this? Take down fast. Methyl. If it is a CH3, CH2, ethyl. If it is CH3, CH2, CH2, if there are at least 3 or more than 3 carbons are there, we use N-isoneo for the common name. N-isoneo. Numbering for IPAC name. Okay, so therefore here you can take it as a N, no? N propyl. So what is the meaning of N? Straight line, normal chain, straight chain. N propyl. Next, CH3, CH, CH3, this isopropyl. Next, CH3, CH2, CH2, one more CH2. Tell me, meth, eth, prop, but. Which butyl? N butyl. Next, CH3, CH, CH3, here is CH2. It is isobutyl. Isobutyl. Next, CH3, CH, CH2, CH, CH3, and tell me, this is secondary butyl. Next, it is tertiary butyl. Tell me, how to identify N-isoneo, secondary, tertiary, etc. Do you understand what is the meaning of N? It is normal chain. Iso, there is one branching. Neo, two branching. So usually remember, N-isoneo, all three are having primary carbon except isopropyl. See, this is a isopropyl, it has secondary carbon. But usually N, isoneo always having primary. For example, you see N-butyl, this is which carbon? Primary carbon. Isobutyl, it is also primary carbon. And moreover, in iso there is a branching where 1, 2, 3. From last to where? Second carbon. If there is a one branching from last to second carbon, that is a iso. Right. And next, now can you tell me, can we take this is also one branching? Is it iso? No. Why? So N iso neo should be primary, but is it primary the carbon? This is secondary carbon. That's what secondary butyl. Next here, it is there are two branching actually. Can I take it is a neo? No. Why? N iso neo always primary. This is what? Tertiary. Therefore it is a tertiary butyl. Okay. For example, now tell me, let us take first for a 5 carbon pentyl. Okay, for 5 carbon pentyl, it is CH3, CH2, CH2. Tell me, what is this? Is it N pentyl or not? N pentyl. Why N pentyl? Normal chain. It is no branching. N pentyl. And moreover, when you say N pentyl, this carbon must be primary, because N iso neo always primary. Next, if I write one branching on last to second carbon, tell me, is it iso or not? So you need to identify this carbon is primary carbon. If it is a primary carbon and branching is there, that is iso. Right? Next, there are two branching. Tell me. There are two branching. Where two branching? From last to second carbon, and this is carbon is primary. It is what? Neo, not butyl, sorry, pentyl no. Iso pentyl, neo pentyl no. 1, 2, 3, 4, 5. Neo pentyl. Now tell me, in N iso neo, N normal chain, iso one branching, neo two branching, but in fact 3 are having which carbon? Primary, primary, primary. It means N iso neo always having primary except isopropyl. When you say isopropyl, isopropyl has secondary carbon. Even though secondary, we should not say secondary propyl. It is isopropyl common name. One exception. Then next is if it is CH3, CH2, CH, CH3. This is one. There is a one branching. It is two branching. Tell me now, can I take it is iso? No. Why? Naveta, why? Why it cannot be taken as a iso? One branching is there. Even though one branching is there, whether this carbon primary, secondary, tertiary? This carbon attached to adjacent carbon? No. Secondary carbon. Since it is a secondary carbon, it is not a iso, because N iso neo always primary. Right? Therefore, it is a secondary pentyl only. Next, can you take it is a neo? There are two branching, two methyl group branching. No. Why? Because this carbon is a tertiary carbon. If you say it is a tertiary, neo, it should be primary carbon. Then if two methyl groups are here, then you could have say, but this is tertiary. Therefore, it is tertiary pentyl. Okay? Take down. Take this and write one note. So So it is about alkane, alkyl. Next, similarly we have alkene, alkenyl, alkyne, alkenyl. Some more example for that category. Let us take alkene. It is CH2 double bond CH. Huh? Yeah, ethene, ethenyl. CH3, CH double bond CH. Tell me, what is this? Propene, propenyl. Okay, but when there are three or more carbons are there, we should give numbering. Which propenyl? It is a 1 propenyl. 1, 2, 3. So right, it is a 1 propenyl. If it is CH2 double bond CH, CH2, it is which propenyl? 1 or 2? It is 2 propenyl. Why 1? Numbering should be here, no? Okay, you are seeing the double bond, but now this is something, it is attached carbon now here. Suppose for example here something benzene ring is there. Okay, it means the side chain started here, no? Something long chain is there, double bond is there, OH is there, something is there, here side chain is there. Okay, side chain double bond is here. Will you give the numbering for this one or this one? Wherever side chain starts, that is one, no? Yes or no? Therefore, we are studying about side chain, means substituent we are studying. When you study about substituent, the substituent attached carbon to the parent chain is, this is 1. Okay. Irrespective it is, what are the bonds are present. Therefore, 1, 2. Now tell me, it becomes what? 2 propenyl. Like butenyl, pentenyl you can write. Similarly, if it is a CH triple bond C, CH3, C triple bond C, CH triple bond C, CH2, write the name. Alkyne, alkynyl. So what about this? Ethynyl. Next, it is 1 propionyl. Next, it is 1, 2, 3. 2 propionyl. Okay. So this is a side chain we are studying, like substituent. If the side chain contain this group, you should write 2 propionyl, like that. Okay. One important note, sometime side chain has like CH2 double bond, okay, which is called alkylidine, methylidine, ethylidine. If there is a CH double bond, this is methylidine. Like for example, cyclohexane. This cyclohexane has CH2. Okay. Now this is named as now methylidine. Okay, methylidine substituent. Then what about the parent chain? Cyclohexane. Therefore, what is the IUPAC name? Methylidine cyclohexane. If there is a numbering is there, 1 methylidine. You can give 2 methylidine, 3 methylidine numbering. Therefore, this CH2 groups comes as a substituent, we should write methylidine. Next, similarly, if CH3, CH double bond, this is like ethylidine. If this CH2, CH3, CH comes as a substituent, which is called ethylidine, propylidine, etc. Okay, so alkylidine is the name. It is about a substituent. So this is primary and secondary prefix. So primary prefix indicates what? Molecule, cyclic or acyclic. Secondary prefix indicates what? Molecule containing which substituent. So all these are substituent. So in substituent, very commonly, very important is alkyl. So these are all different alkyl, alkenyl, alkynyl substituents. Next is suffix. Suffix. Right. So what is suffix? It is of two types, right? What are two types? One, primary suffix, secondary suffix, right? Let us take a primary suffix. Tell me. So what is a primary suffix? What does primary suffix indicate? Primary suffix indicate the presence of nature of carbon bond. It indicates the nature of carbon-carbon bond, whether nature of the carbon-carbon bond single bond or double bond or triple bond. And what about secondary suffix indicate? It indicates the nature of functional group, right? Write down. Primary suffix, it indicates nature of CC bond, carbon-carbon bond. It indicates the presence of carbon-carbon bond or nature of carbon-carbon bond. Okay. So take this nature of CC bond and primary suffix. Tell me. So nature of CC bond and primary suffix. If the carbon-carbon bond is like a carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond. Tell me, if it is a carbon-carbon single bond, what is a primary suffix is? Ane, A-N-E, ane, alkane. It is ene. Triple bond, ine. Ane, ene, ine. But if there are two double bonds, two triple bond, it is a diene, it is diene, diene, triene, tetraene. Okay, so it is diene. But important is one carbon-carbon double bond is there and one carbon-carbon triple bond is there. What is this? It is a ene-ine or ine-ene, which is correct? Ene-ine correct, ine-ene correct? Ene-ine correct, because according to alphabetical order, ene come first, ene, ene. Therefore, it is a ene plus ine. But ene plus ine, which is equals to ene-ine. So what should be removed? Letter E. Why? Here, ene plus ine, this is a primary suffix. It is a secondary suffix. Okay, this is primary and it is secondary suffix. See, if secondary suffix, there is a rule. If the secondary suffix starts with A, comma, E, I, O, U and even Y also. If the secondary suffix starts with A, E, I, O, U, Y of any one of this letter, from the primary suffix remove the last letter, that is E. Right? Because secondary suffix starts with Y. When secondary suffix starts with any one of this letter, from the primary suffix remove the last letter. Here last letter is E. Therefore, it become ene, ine. Okay. So write down. Have taken this. Right. Right. If secondary suffix starts with, if secondary suffix starts with A, comma, E, comma, A, E, I, O, U, Y. A, E, I, O, U, Y. Then remove the last letter from primary suffix. Then remove the last letter from primary suffix. ಯಾರು ಕ್ಲಾಸ್ ಬಂಕ್ ಮಾಡಿದ್ದಾರೆ? ಹರ್ಷ ಇಲ್ಲ, ಹರ್ಷ ಟಿ ಜಿ ಇಲ್ಲ. ಲಾಂಗ್ ಟರ್ಮಲ್ಲಿ ಯತೀಶ್, ಗಿರೀಶ್, ಆಕಾಶ್. Okay, so it is about primary suffix. Next is secondary suffix. Secondary suffix. Tell me. So what is secondary suffix? It indicates nature of functional group. Primary suffix indicate nature of carbon-carbon bond. It indicate nature of functional group. Then what is a functional group? Functional group is it may be a group or atom or group of atom. So therefore atom or group of atom which decides the property of the organic compound. For example, you can take methane. Methane is a hydrocarbon. In methane, just remove one hydrogen, add OH. It becomes what? Methyl alcohol, methanol. Therefore, methanol is completely different from methane. And the methanol property is depends on OH. Where OH is a what? Functional group. So therefore, functional group is it may be a atom or it may be a group of atom which decides what? Nature of the property of the organic compound. Okay, then we have some important functional group and their IUPAC names and all. Right. Secondary suffix, it indicates nature of functional group. It indicates nature of functional group. Right. Functional group. Write the definition of functional group. The atom or group of atom. The atom or group of atom which decide the atom or group of atom which decide the what? Property of organic compound. Which decide the property of organic compound called what? Functional group. Okay, so take functional group in first column. In second column, what is secondary suffix? Tell me. If the functional group is COOH, which is called what? Carboxylic acid. Tell me, what is the suffix? Oic acid, which is also called alkanoic acid. Next, if it is SO3H, sulfonic acid, no? Okay, its name is same, sulfonic acid. Sulfonic acid. Next, if it is a ester, ester. So what is the secondary suffix? Alkyl alkanoate, right? Alkanoate. Alkyl alkanoate. If it is CO, C double bond O, it is acid anhydride. Right? Acid anhydride. It is oic anhydride. Oic anhydride. Next, C double bond OX, oil halide. It is a acid halide. Next, C double bond O NH2. It is amide. It is called alkanamide. Alkanamide. Next, if it is a OH, it is ol. Aldehyde. Al, all. Ketone. C double bond O. Ketone. It is one. Alkanone. If it is SH, which is called thioalcohol. Thioalcohol, it is a thiol. Thiol. Next, if it is a ether, like alkoxy alkane. Ether, alkoxy alkane. Okay, so all covered. It is about a secondary suffix. Okay, then now what is the format of IUPAC name? Suppose if I write IUPAC name, the IUPAC name of, can you tell me this? What is IUPAC name of this? If methyl is there, OH is there, something is, okay, fine, tell me. What is IUPAC name? We know that numbering start from OH 1, 2, 3, 4, 5, 6. Come on, tell me. 3 methyl. So it is a 3 methyl cyclohexane. Which ol? 1 ol. Tell me, in this IUPAC name, which will, no, what is written first? 3 methyl. It means what? Substituent. So substituent is nothing but which prefix? Secondary prefix. Therefore, in the format of IUPAC name, we write first is secondary prefix. Next is what? If there is a primary prefix, then we write next. So that is after this we write primary prefix. Okay. Once in JW they asked a question like this, they have given preference. Most of the students get confused. Primary written, this is not primary. Secondary prefix comes, then primary comes. Next is root word, right? Cyclo, then hexane, no. Cyclohexane alkane. It is root word. Next is ane, ol. Ane is what? Primary suffix. Then lost in secondary suffix. It means root word is middle, right? Before root word or root word attached to primary prefix, primary suffix. Root word attached to primary prefix, primary suffix. Then primary prefix, secondary prefix, primary suffix, secondary suffix. So remember like this. This is this. Okay. ಭಾಳ ಆಗಿದೆಲ್ಲ ಸಾಕಾ? More than, yeah, more than one functional group is there, then what? Then Now we are entering into the IPAC nomenclature. Okay. ನೀವು ಅವಾಗೆ ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆದ್ರೆ ಹೆಂಗೆ? ಅದಕ್ಕನ್ನು ಜಾಸ್ತಿ ಇದ್ದರೆ ಒನ್ ವಿ ಟೇಕ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫಂಕ್ಷನ್ ಗ್ರೂಪ್, ರಿಮೈನಿಂಗ್ ವಿಲ್ ಟೇಕ್ substituent. There is a one order. Okay, so that is in next class we'll start.